This 3D print looks like it might have been done by a multicolor printer, but it wasn't. It was done with a printer that had only one extruder. The letters are embedded in the base. They're actually a millimeter deep into the base. Let me show you how easy it is to do this. I'm sure many of you already know this trick, but for those of you who don't, here it is. This is two prints. The yellow letters were printed in one project, and the base with spaces for the letters was printed in a second. And the real trick, I think, was to use software, OpenSCAD, that lets you do this really easily. Here's the OpenSCAD interface. It's a little bit different than most design programs in that you don't drag and drop objects in order to create them. Instead, you ask for things with verbal instructions. So on this panel here, I have the code for two different renderings. The first one is very short. It's up here, and it's really composed of only the one line. The second one is down here. It's got a few more lines, so you would write one of these or the other, not both in the same place. And what I've done is I've used the C++ designation to comment out lines. So the double slashes at the beginning of a line are telling the program ignore all the rest. And what I've allowed is just one line, this one here, text, etc., to be rendered. Here's what the rendering looks like on this side. So let me get into some of the details of this code. The render that I want here is a two-dimensional object. So in OpenSCAD, in the OpenSCAD world, text is a two-dimensional object, and then you specify what you want. So GJF, obviously, that's the text that I want printed. I want it to be 20 millimeters in size. The font that I want it to use is memory, and then the spacing 1.1. Let's ignore that for now because it's not too relevant. Now this is a two-dimensional object. If I wanted to have some height, then I would have to extrude it. So let me uncomment that line and then press F6 to get the rendering. And now you can see that the letters have been given some height, specifically 2 millimeters in this case. That's all you need to create the letters. So that's one program. Now let me comment that out. And I'll hit F6 now, and just remembers that there used to be something, but let's ignore it for now. Now, the other thing that you want to render is the base plate. And so the base plate starts off life here as a cube. So now remember, this is one program that would be written alone, and this is a separate program that, well, in this case, we've commented out everything, but it would not even be here if you wanted to print. So here's the base plate on its own. Let me hit F6 now. And you can see that it's a base plate. Happens to have 60 millimeters in length, 30 millimeters in height, and 3 millimeters in thickness. Okay, let's ignore that for a bit, and let me take you down to the text again. So here's the two-dimensional text, F6 now. Two-dimensional text, and I want to extrude it as well, so I'll comment that out and hit F6 again. Okay, so there's the lettering. Now, take a look at this. I have a difference instruction at the top of everything, and the way that that works is it renders the first line, the first instruction, as a positive, and then it removes everything else until it encounters the closing brace. So the difference instruction name is difference with the opening and closing parentheses. And then what you want to embrace with this difference, well, you do it by opening a brace up here and then closing it when you're done. So what that does is prints the first line as a positive, and all the rest gets removed. So what we have here is where the cursor is a two-dimensional text rendering. It's been extruded to have a 2 millimeter height. Now I also wanted to give it a little bit of fatness. So I've added this offset of 1/10 of a millimeter. This might vary from print to print, but when I hit F6, you'll see that the lettering gets a little bit fatter. So I'm going to hit F6 now, and it got a little bit fatter. I'm not sure if you spotted it, but it did. Okay. So here's the lettering now shown as a positive sitting at the base. I have not yet engaged the difference instruction. Now I want to change its position a little bit, so I'll translate it. So backspace, backspace, and then hitting F6 now. So it's moved. It's moved down 5 millimeters, so down meaning to the right. It's moved up 5 millimeters in this direction. And I've also raised it 2 millimeters off ground. So let me rotate this around, and you can see that it's above the baseline by 2 millimeters. Okay, now we still don't have the difference instruction engaged, but let's put the cube back in, F6 now. And right now the program is interpreting all of this stuff as positive. So the base plate is being printed, and then embedded in that is this lettering. The lettering is sitting proud by a millimeter just because of the way I've positioned it. So that's pretty good. Now let me embrace the difference instruction. What you're going to see with the difference instruction is the base plate comes out as a positive, and the text will come out as a negative. So I'm about to hit F6 now. And now we have the base plate printed along with the recess needed to accept the lettering. So the last little bit of this is to print the letters themselves alone in one color, as we saw earlier. And then in a separate print, you print the base plate along with the space that it's allowed for the letters. And remember, this offset over here makes the recesses a touch wider than the letters themselves. And that extra bit of offset, you might have to play with that a little bit to get it just right for your printer. But that's the simple, basic way that you get what looks like two-color printing. Cool, eh? Listen, bye from me for now.